This is where we combine our matrices with solving systems of equations. Now, when you actually see this starting to happen, you're going to ask yourself, why in the world would we want to solve a system like this when we can just solve it those easy ways like we learned at the beginning of this chapter? Well, sometimes you're going to have systems of equations that are this big, which we did have in one of our sections. We could even have systems of equations with 5 unknowns, 5 equations, or 10 unknowns. I mean, there's an unlimited number of unknowns we could have, especially when you apply it to the real world. And business is a great application of systems of equations. However, we're not going to get into that point in this particular topic. So we do have to start off with a smaller example to build up to these larger examples. Okay, so I don't want you to automatically think, oh, this is just crazy. Why would we ever do this? Well, it's because we're building up to something much bigger. So before we do anything else, we have to know what an augmented matrix is. An augmented matrix is where you take all of your coefficients, make sure they're all in the correct order, XYZ, XYZ, XYZ. Take all of your coefficients and put them into a matrix. When it is an augmented matrix, it means it has this line in it right here. Okay? On the right-hand side of your line are your constants, 7, 4, negative 10. So you do need to know how to set up your augmented matrix before you can do anything else to it. So just like learning rules of logarithms, you know, the logarithm game, we have to learn the matrix game. And to learn the matrix game, you have to learn the rules. Well, these are the rules. You are allowed to arrange the rows. You can add 2 rows together. You can multiply or divide any row by a constant but not 0. And you can combine any of these 3 rules. So those are pretty much the only rules that you have to follow. But you know how whenever you play games, especially strategic games, sometimes there's like little hints. Well, if you want to do this, then do this. Well, let's look at these little hints that I'm giving you. You can rearrange the rows, but you really only want to do that during the first step. And it's not always the first step, but almost always it's only the first step. Okay? And by the way, we're looking for 1s and 0s. So that's why we have all of these little hints over here. You can add any 2 rows together, and you want to do that if you want a 0. So when you want a 0, you add. You can multiply or divide by any number except 0, of course. If you multiply or divide, it's because you're wanting a 1. So keep that in mind. Add for 0, multiply or divide for 1. Then you can combine any of the above rules. Usually that combination is multiply then add. And you do that if you want to get a 0. For example, let me see if I can just make this up really fast. Okay, remember when we had this, well, let's make this 3 right here. Remember when we had a system of equations like this? We can multiply this one by a 2, then add them together, and that would make the y's cancel, right? If you multiply negative y times 2, you get negative 2y. Add together and you get 0. That's what the multiply then add means. You multiply them by 2, then you add them together and you get a 0. Okay, so we're still doing the same thing, we're just doing it in a different way. So let's practice some row operations before we actually start using Gaussian elimination. This means, let's just say we're going to switch it with row 3. I'm not sure what your notes say, but I'm going to make it row 3. This row operation notation means we switch rows 1 and 3. So for A, row 3 becomes row 1. And row 1 becomes row 3. Row 2 was not affected by this row operation. That's all you have to do when you switch 2 rows. Literally, just switch them. So part B says to find 1/3 of row 1. Usually there's a little bit more to this row operation. So 1/3 of row 1 is really the same thing as row 1 divided by 3, if you like to see it in that form. This gives us a new row 1. This is your row operation right here. So for B, it's telling us that we're getting a new row 1. That means rows 2 and 3 do not change. But everything in row 1 gets divided by 3. So you'll have 1/3, negative 2/3, and then 3 divided by 3 is 1, and then 7 divided by 3 is 7/3. Then we have C. C says 2 times row 2 plus row 3. Normally it would say gives us a new row 3. Okay, these row operations, this notation is very important and you will be graded on that on your test. So make sure you know what these row operations mean. For part C, it says we're getting a new row 3. That means rows 1 and 2 do not change. It says 2 times row 2 plus row 3. 2 times row 2 plus row 3. 2 times 2 is 4. 4 plus negative 3 is 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 1 is 2. 2 plus negative 2 is 0. 2 times 4 is 8. 8 plus negative 10 is negative 2. We just did 2 times row 2, so 2 times all these, and we added it to this row to get a new row 3.